Traffic accidents at a four-way stop sign can be just as deadly as regular intersections. According to ICBC, there were 30 severe accidents at a four-way stop intersection in a residential area alone from 2014 to 2018. CrossWatch aims to reduce this traffic accident rate through Watchbox. Watchbox can be divided into four parts: vehicle detection with LiDAR sensor, pedestrian detection with microwave sensor, vehicle turn signal through image processing, and queuing system for the intersection. Due to COVID-19, CrossWatch members had to work on different parts individually and share data through the internet.
Hi, Richard here. Me and Jonsen will mainly work on the hardware developing of the watchbox, and I will mainly work on the LiDAR sensor for the vehicle detection. So here is one side of the watchbox. This is the LiDAR sensor. This is the Arduino Uno to collect the data, and here is a 7-segment display to show you the car number, and here is a siren speaker. It will trigger if the LiDAR detects speeding vehicles. On the terminal screen, we can see the distant LiDAR sensor detected, and if I tell the LiDAR sensor to different angle, it will show you different distance. And if I put this directly to the window and on the terminal, it's showing you 1 centimeter. That means LiDAR detects nothing, or the object is out of the range. By using the distant LiDAR sensor detected, we can calculate the vehicle speed, and if it detects some speeding vehicle, so the siren speaker will trigger and it will alarm pedestrian for the dangers. In a real scenario testing of vehicle detection, and we can see the LiDAR detects the car, and the current number go from 0 to 1.
The watchbox side to Jonsen. Okay, here we go.
2,000 years later.
At Jonsen's house, and I'm here with one watchbox to aim, so he's here.
So the benefit of the HB100 microwave module would be the capability of detecting an object moving directly towards it and away and determine its relative speed. With this, we can determine the direction, whether the pedestrian is approaching or leaving. At one corner of the intersection, there will be a path like this and a path like that. So we'll be placing one HB100 like this for this direction, and one HB100 over here for this direction. So the first test for the HB100 microwave would be the capability of detecting a pedestrian represented by this booklet approaching. So if I'm right here, I'm going to move close. So if I do move close, you see that the code does detect that the pedestrian is approaching. Next test would be that the pedestrian's already in the range of the HB100 and I'm going to leave. So if the pedestrian leaves, that terminal do see that the pedestrian is leaving.
For a real scenario testing of the pedestrian detection, as we can see Jonsen is approaching the stop sign, the microwave shall detect him, so the current number go from 0 to 1, and on the terminal it shows pedestrian detected.
I am Dustin. I am responsible for the image processing for our product. Simple result, left turn. The left side of the screen shows that the vehicle is having left turn signal. The right side of the screen is a testing result. By inputting the video name of the car turning left, it will result vehicle is turning left. Simple result, right turn. Same as before. Input the name of the video, it will result vehicle is turning right, as the input video shown on the left. Simple result, straight. This is the input of vehicle without turn signal. Therefore, the test result is vehicle going straight, as you can see on the right side.
After the image processing part, the next step is to feed results from our sensors and image processing into the current system in order to get priority number on the 7-segment display. Due to the COVID-19 pandemic, CrossWatch members cannot all go outside and simulate complex scenarios. So the CrossWatch engineer designed a manual input current system to manipulate complex scenarios.
Hi, I'm David, and I mainly work on designing the logic for our queuing system, as well as helping Brian and Dustin on image processing. So now I'm going to show how our queuing system works by doing several test cases. So here's our first test cases. So we have a vehicle 1 here at corner 1 wanting to turn right, and we have a pedestrian wanting to go across. So I'm going to run the script and enter the test case information for our test case 1. So as you can see, we will have pedestrian first in the queue, and then it has priority 1, and the queue number for the corner 1 vehicle is 2, because I have to wait for the pedestrian to proceed. So now I'm going to show a test case which involves 2 pedestrians and 2 vehicles. As you can see, we have vehicle 1 here trying to turn right, and vehicle 3 are trying to turn left into the same lane. And 2 pedestrians are going at the horizontal direction of these pictures. And then vehicle 1 approaches first before vehicle 3. So now I'm going to enter test information for this test case first. So as you can see, we have 4 items in the queue, 2 pedestrians, 2 vehicles. And because vehicle 1 approaches first, the queue number is 2, and then vehicle 3's queue number is 3.
Here is an example of our device working with live pedestrian and vehicle. In the beginning, the current number is 0, and watchbox detects a pedestrian enters the intersection, and current number is increased to 1. The device soon detects a vehicle, and the current number goes up to 2. The total cost of one watchbox is roughly 350 Canadian dollars.